Hi everyone, let's take a look at the following example. Find the antiderivative of sin x times sin x or sin x squared times cosine x with respect to x. Step number one, if you think about this, you have to use the method of substitution. So that means you have to let u be one of the parts such that the derivative is a scalar multiple of the other part. Now, how do we do this? The general rule is you always let the more difficult part be u. So in this case, there is sin x and cosine x, but notice how it's sin x squared. And that square is trying to signal to you that it's a little bit more difficult. So what we're going to do is let u equal to sin u. And of course, if you think about this, du by dx, this equals to cosine x. Again, I will use a different color in a moment to match this for you. The goal is to isolate for cosine x times dx. So again, if you think about cosine x times dx, this equals to, and I'll use a different color here, right here, this equals to du. And likewise, let's switch to another color again. This part, sin x is going to be u. So sin x squared is going to be u squared. Now, if I go back, this means I can express the entire question as the integration of, instead of saying sin x squared, it's going to be u squared. And you're going to integrate this with respect to x. Again, if you go back to the basics, you add the exponent by 1. So it's going to be u to the power of 3. Divide by the new exponent, which is going to be 3, plus a constant, right? And of course, if you think about this, that's going to be 1 divided by 3. U is going to be sin x. And of course, it's going to be sin x in brackets to the power of 3, or you can write it like this, sin x cubed plus c. Now again, if you want to double check this, you can write it down on a piece of paper, or you can double check mentally. If you really think about this, look what happens when I find a derivative. I bring the 3 to the front. 3 times 1/3 is going to be 1 times sin x squared times the internal derivative, which is cosine x. And of course, when you differentiate a constant, that's going to be 0. So this is how you know you're doing it right. I hope this makes sense.